Hi! Today, we will learn about division of radicals. Our objective is to divide radical expressions. If a and b are real numbers, and a is greater than or equal to 0, and b is greater than or equal to 0, then the nth root of a over the nth root of b is equal to the nth root of a over b. Let's first discuss how to divide radicals of the same index. Let's say, for example, we have square root of 10 divided by 5. This is now equal to square root of 10 over square root of 5 or square root of 10 over 5. 10 over 5 is equal to 2. Therefore, the quotient is square root of 2. Another example, divide square root of 24 by square root of 6. This is equal to square root of 24 over square root of 6, or square root of 24 over 6. And 24 over 6 is equal to 4. The square root of 4 is 2. Therefore, the quotient is 2. Another example, divide square root of 8 divided by square root of 6 and simplify. So here, the radicand 8 is not divisible by 6. So we have square root of 8 divided by square root of 6, which is also the same as square root of 8 over 6. As I have said, 8 is not divisible by 6. So what we're going to do is we will rationalize the denominator. So write it back to square root of 8 over square root of 6. So in rationalizing, we will multiply both the numerator and the denominator to an expression that will make the denominator rational. And that expression is square root of 6. Now we have square root of 8 times square root of 6. That is square root of 48. And then square root of 6 times 6, 36. So we have square root of 48 over square root of 36. What we do now is we simplify the radicand. 48 is the same as 16 times 3. This is a factor pair of 48 wherein one of them is a perfect square, and that is 16. Over the square root of 36 is 6. Now let us simplify. The square root of 16 is 4. 3 will be left inside the radical sign, and then we have 6. So we have 4 square root of 3 over 6. If we try to observe, we can still simplify or reduce the fraction 4 over 6 in lowest term, and that is 2/3. Therefore, the final quotient is 2 square root of 3 over 3. Dividing radicals with different indices. To divide radicals with different indices, change the radical to the same order or index. Say for example, we have find the quotient of cube root of 4 divided by 6th root of 2. The first thing that we need to do is to change the dividend and the divisor to exponential form. Cube root of 4 is 4 raised to 1/3. And then 6th root of 2 is 2 raised to 1/6. Next is to make the fractional exponent similar. So we will think of a fraction that is equivalent to 1/3 that is similar to it. So we have 2 over 6. As you can see, the fractional exponents now are similar fractions. What we do next is we write them in radical form. 4 raised to 2 over 6 is 6th root of 4 squared. And then 2 raised to 1 over 6 is 6th root of 2. If you can see, they now have the same index. Let us simplify. This now becomes 6th root of 16. And then we have 6th root of 2. This is the same as 6th root of 16 divided by 2. And that is 6th root of 8. Now, this is not yet our final answer. If you will try to observe, we can still simplify 6th root of 8 by reducing the index. First, let us rewrite 8 in exponential form. 8 is the same as 2 raised to the third power. If we will rewrite this radical expression in exponential form, this will become 2 raised to 3 over 6. As you can see, the exponent 3 over 6 can still be simplified or reduced to lowest term, and that is 1/2. After that, we write 2 raised to 1/2 in radical form. And 2 raised to 1/2 in radical form is square root of 2. This is now our final answer. Rationalizing binomial denominators. Two binomial radical expressions are said to be conjugate if they differ only in sign that connects the binomials. Say, for example, we have the radical expression 5 minus square root of 3. Its conjugate is 5 plus square root of 3. Another example, square root of 2 plus square root of 7. The conjugate of the given expression is square root of 2 minus square root of 7. Now, if a fraction contains a binomial radical denominator, you can rationalize it by multiplying it by its conjugate. Let's have an example. So again, keep in mind that if a fraction contains a binomial radical denominator, you can rationalize it by multiplying it by its conjugate. So for our example, we have rationalize 2 over 3 minus square root of 3. So first, we need to identify the conjugate of the denominator. The conjugate of the denominator is 3 plus square root of 3. If you will try to observe, we simply change the sign. So we have 2 over 3 minus the square root of 3. What we have to do is multiply the numerator and denominator by the conjugate of the denominator, which is 3 plus square root of 3. Let's use or apply distributive property. 2 times 3 is 6 plus 2 times square root of 3 is 2 square root of 3. For the denominator, we are multiplying a binomial by another binomial. Using the long method, we may use the FOIL method. Multiply the first terms, 3 times 3, 9, plus the outer terms, 3 times square root of 3 is 3 square root of 3. Next, we have the inner terms, negative 3 times 3 is negative 3 square root of 3. Then multiply the last terms, negative 3 or negative square root of 3 times positive square root of 3. That will give us negative square root of 9. Let us simplify. We have 6 plus 2 square root of 3. For the denominator, you can observe that we have here 3 square root of 3 minus 3 square root of 3. So that will be cancelled. What will be left will be 9 minus square root of 9. Simplifying this, we have 6 plus 2 square root of 3 over 9 minus the square root of 9 is 3. So we have 6 plus 2 square root of 3 over 9 minus 3 is 6. Remember that this expression, 6 plus 2 square root of 3 over or all over 6, is the same as 6 over 6 plus 2 square root of 3 over 6. Simplifying the fractions, we're going to have 6 over 6 is equal to 1 plus simplify 2 over 6 in lowest term. 2 over 6 is 1/3. So the simplest form of 2 square root of 3 over 6 is square root of 3 over 3. This now will be our final answer. 1 plus square root of 3 over 3. Let's have more examples. Divide. Okay, number 1, we have square root of 45 over square root of 5. This is the same as square root of 45 over 5, and that will give us square root of 45 divided by 5 is 9. Simplifying square root of 9, the square root of 9 is 3. Another example, cube root of x cubed y to the 10th power over cube root of x squared y to the 4th power. This is the same as the cube root of x cubed y raised to 10 over x squared y raised to the 4th power. Applying the laws of exponents, x cubed over x squared, subtract the exponents, we have x, y raised to the 10th power over y to the 4th power, subtract the exponents, we have y raised to the 6th power. Now this is the same, or this expression is the same as the cube root of x times the cube root of y to the 6th power. Y to the 6th power is a perfect cube, and the cube root of y to the 6th power is y raised to the 2nd power. And then x will be left inside the radical sign. So for our final answer, we have y squared times the cube root of x. This now is our quotient. Another example, cube root of 8x to the 4th power over cube root of 2x squared. This expression is the same as the cube root of 8x to the 4th power over 2x squared. Simplify or divide the radicands. 8 over 2 is 4. X to the 4th power over x squared is x squared. If you will try to observe, we can no longer simplify the radical or the radicand for x squared. So this now will be our final answer. Another example, 4 over square root of 5 minus 3. So in this example, we need to rationalize binomial denominators. In order to do that, we multiply the numerator and denominator by the conjugate of square root of 5 minus 3. So the conjugate is square root of 5 plus 3. Square root of 5 plus 3. Now let's multiply. 4 times square root of 5 is 4 square root of 5. 4 times 3 is equal to 12. For the denominator, square root of 5 times square root of 5 is square root of 25. Square root of 5 times 3 is 3 square root of 5. Next, negative 3 times square root of 5 is negative 3 square root of 5. Next, negative 3 times positive 3 is negative 9. Simplify. 4 square root of 5 plus 12 over, for the denominator, you can observe that we can cancel 3 square root of 5 minus 3 square root of 5. That will be equal to 0. So what will be left will be square root of 25 minus 9. So we have 4 square root of 5 plus 12 over square root of 25 is 5 and then minus 9. Okay, we now have 4 square root of 5 plus 12 over negative 5 minus 9 is negative 4. This expression is the same as 4 square root of 5 over negative 4 plus 12 over negative 4. So we can simplify. For the final answer, we're going to have 4 over negative 4 is negative 1. So that will give us negative square root of 5. And then 12 over negative 4 is negative 3. So for our final answer, we have negative square root of 5 minus 3. So that is how we divide radical expressions. Thank you very much for listening.